Let's do another example of implicit derivatives. We have 3xy minus 4x plus y equals 21, and we want to find the slope at -5, -1/14. First thing to do is to find the derivative, and we're going to need to be careful this time because we're going to have multiple dy dx's. Here we go. Let's take the derivative of this thing. First, we take the derivative of 3xy. That means we're going to need to use the product rule because we have x times y. If you remember, the product rule is f prime g plus fg prime. So here we go. That's going to be 3 derivative of x, and then you leave y alone. Derivative of x is 1, so that's just 3y. There's our first term. Notice I do not need to put a dy dx right now because I took the derivative of x. It's really important that you pay attention to which variable you're taking the derivative of. We took the derivative of x, so I write 3y dx dx, but I don't need to write dx dx. I can just leave it 3y. Then we're going to take the derivative of the other function, the fg prime. So I take the derivative of y. That again is 1. But because that's a y, we just took the derivative of y. Now I need to write dy dx. So that's the big idea. We didn't need a dy dx here, but we did here, because here is when I actually took the derivative of y. And that's maybe the hardest thing to understand about this. The derivative of 4x is -4. I took the derivative of x, so I do not need to write dx dx. Plus, the derivative of y is 1. But guess what? We just took the derivative of y, so I need to put in another dy dx. You need to put in 1 dy dx for every y that you take the derivative of. Finally, the derivative of 21 is 0, so I just write equals 0. So here is our differential equation. It is just an equation with derivatives in it. Here's what you should do next. Anything that does not have a derivative, you should move over to the right side of the equation. So subtract away 3y and add 4. Okay, anything that doesn't have a derivative, move over. And this, by the way, is the strategy pretty much all the time. So I dropped my 1 because dy dx times 1 is just dy dx. So that's the first step, move everything without a derivative over. The next step is you can actually factor off your derivative. So just treat it like it's a variable. Just factor off your derivative, and which is great. You can just do that. And then now we only have one derivative left, so we can divide by 3x plus 1, divide by 3x plus 1, and we get our derivative. Negative 3y plus 4 over 3x plus 1. That's it, and it's pretty much that strategy every time. The equations might get more complicated, but that's just a strategy. Now to find the actual slope, you just plug in your x and y values, and then you're done with it. So that's going to be -3 times -1/14 plus 4 over 3 times -5 plus 1. So that means on the bottom, we're going to get -15 plus 1, which is -14. On the top, we're going to get that'll become a positive, so 3 divided by 14 plus 4. And then when we divide by 14, so by the way, that was 4.21428. Divide by 14, -14. Our final answer will be -0.301. And the answer that the book got was a fraction, which we could have also found, -59 divided by 196. So if I do 59 divided by 196, I get the exact same answer. So you can do it with fractions if you want. It takes a little longer, or you can get the decimal. And that's it. That's how you find implicit derivatives. We'll do 2 more examples, I think, and then we'll be, maybe 3 more, and then we'll be done with the entire chapter. I hope you appreciate the power that implicit derivatives can give us.